Hello class, today's study is on limit properties you must know. From the sums and products to quotient, all of them are simply explained in this particular studies. Now let's move to the next section, which talks about multiplying a function by a constant. Now, if you multiply a function by a constant, the limit of the product is the constant times the limit of the function. So that is the property, the rule when you multiply a constant by a function. So for this case, mathematically, we can say that the limit as x approaches a of a constant k multiplying the function f of x will be equal to the constant k, then lim x approaches a of f of x, where k is a constant and the limit of the function exists. For example, we have lim 5 multiplying 3x plus 8. In this case, 5 becomes the constant and 3x plus 8 becomes the function. So what will be the limit when 5 multiply 3x plus 8 as x approaches 2? What we are going to do is, the rule is saying that the constant k will be outside, then we find the limit of the function. So here 5 will be outside and we are going to write lim x approaches 2 of 3x plus 8. So what is the limit of this particular function when x approaches 2? Then we are going to have 5 times. It means that to find the behavior of this particular function as x approaches 2, we substitute the 2 to find the approximate value, and that will give us 3 times 2 plus 8. And the result will be 5 times 6 plus 8. And 6 plus 8 will be 14. Then 5 times 14 equal to 70. So that is the rule of multiplication or multiplying a function by a constant. Now let's move to the next rule, which is the power rule for a limit. It says that if n is a positive constant and the limit of f of x as x approaches a exists, then lim x approaches a of f of x power n will be equal to finding the limit of the function f of x, all of them raised to the power n, be the same as f of a all power n. Now, it means that if the limit of x mapped to a or x approaches a of f of x equal to L, then the limit of f of x power n as x approaches a will be L raised to the power n. Let's look at an example at this section. We have to evaluate lim x approaches 2 of 3x plus 1 all power 2. So here the power rule is such that we are going to find the limit x mapped to 2 of 3x plus 1 all raised to the power 2. So in this case, how do we find the limit, the approximate number, as x getting closer to 2? We substitute the 2 as our x. When you do that, we get 3 times 2 plus 1. And 3 times 2 will give us 6 plus 1 here. And 3 times 2 plus 1 will be 6 plus 1, which is equal to 7. Then the power will be on the 7. So 7 power 2 will give us 49. That is the reason why we are saying that if f of x of limit x approaches a is L, then the limit of f of x as x approaches a power n will be L power n. So here our L becomes 7. Then the 2 here will be as the power or the index. So 7 power 2 will give us 49. Now, let's move to the next rule. And the next rule is about the rule of sum and differences. So now sum and difference rule is what we are going to deal with at the moment. So here, if limit of f of x and g of x exists as x approaches a, then the limit of x approaches a of f of x plus or minus g of x, so it can be plus or it can be minus, will be equal to the limit as x approaches a of f of x plus or minus the limit x approaches a of g of x. So what it simply means is that you just split the two functions and find the limit of each respective function. So now, this rule allows us to break complicated expressions into manageable parts. So anytime you get a complicated expressions or functions and you want to find the limit, this rule helps us to break them into separate functions for us to find the limit of each separate functions as x approaches or get closer to a. So now let's see an example. Here we are supposed to evaluate the limit as x approaches 2, that means x getting closer to 2, of these two particular functions, which is 3x plus 1 plus x squared minus 4. So what are we going to do? Using the rule, we are supposed to split the function and find the limit for each respective function as x get closer to 2. So it will be limit as s mapped to 2, 3x plus 1, plus limit as s mapped to 2, x squared minus 4. So in this case, when you find the limit of this function, it means that substitute 2 as x as the input for x. So the input for this function will be 2. So 3 times 2 plus 1. Then repeat the same thing for the next function here. We have x as 2, 2 squared minus 4. Then 3 times 2 plus 1 will be 6 plus 1. Then 2 squared is 4, 4 minus 4. Then we end up with 7 plus 0, which is equal to 7. So the limit for this particular function is equal to 7. Now let's move to the next rule, and the next rule is known as product rule for limits. What does the product rule says? If both limit of f of x and g of x as x approaches a exist, then the product rule of limit states that the limit as s mapped to a of f of x times g of x will be the same as limit as s mapped to a of f of x times limit as s mapped to a of g of x. It means that find the limit of each respective function and multiply their results. So which will be f of a times g of a. So now it is like saying if one machine produces 3 units and another machine produces 5 units at the same input. So here the input will be A. Then together they produce 15 units. How did I get a 15? That will be 3 times 5. So the limit for the first machine, the result is 3. And the limit for the second machine, the result is 5. So if I want to find the total input or what the machine will produce, it will be 3 times 5, which is equal to 15. So here the limit of a product is the product of the limit only if both limits what exist. That is what we need to take note of. So we have an example here to evaluate lim as s mapped to 1 of these two particular functions multiplying themselves, that is in the form of multiplication product. So what are we going to do? We are going to split the two functions and find the limit for each respective function. And this will be the limit as s approaches 1 of 2x plus 1 times the limit as s approaches 1 of x squared plus 3. When we do that, we're going to have 2 times 1 plus 1 times 1 squared plus 3. And 2 times 1 will be 2, so 2 plus 1 is 3 times 1 plus 3 is 4. Then 3 times 4 will give us 12. So this is all about the product rule for the limit. Now let's move to the next rule, which is known as the quotient rule. For the quotient rule, it says that if both limit f of x and g of x as x approaches a exist, then the limit as x approaches a of f of x divided by g of x will be equal to lim f of x divided by lim g of x as x approaches a. That means we are going to find the limit of each respective function for f of x, which is the numerator, and the g of x, which is the denominator. Then divide their results. So you find the limit for the numerator and also find the limit for the denominator. Then you divide their results. This is only possible if g of a is not equal to 0. It means that we are not talking about g of x here. We are talking about g of a. That is the limit value, approximate value, when you substitute the a as your input. So the moment you substitute the a and you end up getting g of a equal to 0, it means that something has to be done. So if direct substitution leads to g of a being equal to 0, then always we are going to use simplification to get our answer or our approximate value. Then always simplify using 1, complete factorization for polynomials, and 2, rationalization for square root. Now let's look at an example at this section. We have limit x approaches 2 of x squared minus 1 divided by 2x plus 3. First, we need to understand that the quotient rule says that we have to find the limit for the numerator and the limit for the denominator, then divide it to get our results. So when you find the limit for the numerator, we are going to get 2 squared minus 1 because you are going to substitute s as your 2. Then the result will be 2 squared minus 1 equal to 3. Then the denominator 2. The result will be 2 times 2 plus 3 equal to 7. So our answer is 3 over 7. This becomes our answer because our g of a is not equal to 0. Our g of a is rather equal to 7. Now let's proceed to the next example, which is example 2. We have to find the limit as x approaches 1 of the function x squared minus 1 divided by the function x minus 1. So x squared minus 1 is our f of x and x minus 1 is our g of x. Each of these functions are polynomial functions. When you substitute the 1, you do direct substitution, the denominator of the function will be 0, which is undefined. Hence, we need to solve or find the limit as x approaches 1 of this function using factorization. Now, before we continue, we have to completely factorize the numerator. When you factorize it, we have a numerator of difference of 2 squared. It will be x plus 1 and x minus 1. The denominator is x minus 1. So x minus 1 and x minus 1 here will cancel out, and our results will be limit as x approaches 1 of x plus 1. We then substitute the 1 as our input to get our answer to be 2. Let's look at example 3, where we have a square root as in the function as the numerator, and we have x here. When you substitute x to be 0 in this function, we are going to have the denominator being undefined. The expression will be undefined because the denominator will be 0. So we are going to use the principles of rationalization to break down this function to be able to find our limit. What are we going to do in rationalization? We multiply both the numerator and the denominator by the conjugate of the set. So here the conjugate of this set will be square root of x plus 4 plus 2. So these are the conjugates. This is the conjugate of the set that we have here. We multiply the numerator by the conjugate and the denominator by the conjugate of this particular set. At the end of it all, we have to remember that we are going to use the identity a plus b, a minus b, which is the same as a squared minus b squared. That is difference of 2 squared. So that is what has happened to the numerator. We have plus here, and we have plus here, and we have minus at this section. So this one is difference of 2 squared. So when you want to simplify the expression, we end up with square root of x plus 4 all square minus 2 all square. So here we are going to take the first one, a square, then minus b square. So this one become our a all square, this one become our b all square. Then we end up to simplify the expression. The square will cancel the square root, and 2 square will give us 4. So the square root is off from the expression. Then 4 minus 4 will be 0. So here we are going to get x here. Then remember, x is also down here when you multiply the denominators. So here the x and the x will cancel, and our results will be 1 divided by square root of x plus 4 plus 2. So when you do that, we are still going to find the limit as s approaches 0. So we are going to do our direct substitution where anywhere we see x, s will be 0. When you do that, our results will be 1 divided by 2 plus 2, which is equal to 1 over 4. Now, we have a practice section for you to try your hands on them using all these rules of limit. So we have the first one, the I here, the I, and the I. Try your hands on these particular questions and send your results to us. Don't forget to follow and subscribe to this particular channel to continue receiving the best of high school maths education. Thank you.